Is the following series convergent or divergent? Today we're going to answer that. So we have this series, which is 1 over negative 1 to the n times 2n plus 3 to the n. Now, when you do this, please ask yourself, what can I do here? Compare all the tests in your head, right? It might be a little hard. Hopefully, you might have a cheat sheet lying around so you can look and just see, okay, can I do divergence test? Can I do this test? No. Okay. So divergence test we will see is important here, but let's go through the other tests in our head. So we have the integral test. Can we do an integral of that quite easily? Well, you'd say no, it's kind of hard. Comparison test, maybe not, because we have the -1 operator there. It's a little bit hard to get something that we can compare it to. Limit comparison test comes from the failure of the comparison test, so we don't do that. That leaves us with absolute value test and those other niche tests that we'll talk about later throughout these practice problem series. But absolute value test, or sorry, not absolute value test, alternating series test here is what we're going to use. Because we have that -1 operator. We could use the absolute value test, but for this problem, they ask us to use the alternating series test. So that's what we'll use. And a key identifier of this is, notice we have this -1 to the n. Hopefully you've seen this, but what it does is it says, okay, if I plug in an odd value, I'm going to get -1, because anything -1 to an odd power will be -1. However, if we take an even power, that's going to make it positive. So it flips back and forth every other term, a positive, and then subtract, and then add and subtract, and add and subtract until you get to your infinite term. Now, something important here to note is that, I'm losing my train of thought, but anywho, what I want to do is do both of the tests. I have identified that as alternating series test because of this operator here. Now what we have to do is expand on that and say, okay, does it pass our tests here? All we need for the alternating series test is for the sum to be positive. Our first term will be positive, and that's going to be the greatest value, as we'll see. So yes, it's going to be a positive sum, but what I need to identify here is, okay, first, does it pass the divergence test? But the divergence test of just a sub n without the operator. So basically this is divergence test, but take out the -1 operator. So what this says is, take the limit as n approaches infinity for 1 over 2 to the n plus 3 to the n. Okay, quite simple. You do that and you're going to see it's 1 over infinity, which is just 0, which is indeterminate. Alrighty, so this is when you pass the divergence test, because notice if we are going to simplify to 0, that neither tells us divergence or convergence. And that's kind of important, because if we got any value other than 0, we know this would be divergent, and therefore we could just move on, call it divergent, and call it a day. Okay, so we pass the divergence test. The second part of this is our a sub n, excluding the operator, is that going to always be decreasing? And to solve this, you could either take a derivative or do a comparison. Now, to do this, you can't really take the derivative of that. It would just get really long and tedious to do a quotient rule. So instead, I'm just going to compare it to another one of itself. Now, we're going to compare it to 1 over the next term in the sequence. So 2 to the n plus 1 plus 3 to the n plus 1. Now, notice what would be true here. Before we even talk about reciprocating just that, let's just talk about it normally. Which one would be greater? Would this be greater, or would this be greater? Well, if you're increasing the exponent, you're increasing the amount of times you multiply something by itself. Therefore, this is greater, and probably greater by a lot when you get up to the really high powers. Alrighty, so this would be true. But notice we take the reciprocal. We put in the denominator. So when we grow something in the denominator, that is going to decrease its overall value, and therefore, this is true. So it flips the inequality when we take the reciprocal. Alrighty, so what does this tell us about the series for any term n, right? when we increase our term, we're decreasing our sequence, right? Therefore, decreasing the sum. So hopefully this idea makes sense. Our sequence of terms is decreasing, right? You'd say even this is true. 1 over 2 to the n plus 2 plus 3 to the n plus 2, okay? So we passed both tests. Divergence test, we passed. All right, decreasing test. Is it decreasing? You'd say yes. So we passed both tests, and therefore it is a convergent series, right? We can say for certainty convergent. If you don't pass the divergence test, well, obviously you're divergent. But if you don't pass the divergence test and you're increasing, well, remember you're kind of growing your series, so therefore it's going to be divergent instead of convergent. So here we'll say convergent. Hope you guys enjoyed this. If you did, please drop a like, comment, and subscribe. I'd greatly appreciate it, and I hope that you have a wonderful day.